Hello everyone, welcome to my YouTube channel. If you are new for my channel, please subscribe. Thanks. Today I am going to discuss about glycolysis. This is the second part of glycolysis discussion. I made the first part previously as a quick revision. These things are biochemistry, and also glycolysis is a metabolic process. Generally, there are two kinds of metabolism or metabolic processes, such as catabolism and anabolism. What is just catabolism means? Catabolism means converting the things we get from foods, such as carbohydrates, proteins, and lipids into ATP. Okay? So this is what we call catabolism or catabolic process. ATPs are important for cells. Each and every activities of cells are with the help of ATPs. And cells cannot utilize these foods or these molecules, larger molecules. There should be converting these molecules into the utilizable form of energy, that is ATP. So the major process of converting these are glycolysis and TCA cycle. Yes, we are going to discuss about glycolysis. The glycolysis has 10 steps. Just to capture or memorize the 10-step metabolites, I made very simple sentence for you. Read this sentence, and it also found in the previous video. In today's discussion, we will look at the whole process of glycolysis. In the process, there are 10 enzymes. What are the 10 enzymes in the process are these, such as hexokinase or glucokinase. Hexokinase is in all kinds of cells. It's found in all kinds of cells. Glucokinase is only in liver cells. The other enzyme is phosphoglucose isomerase, phosphofructokinase, aldolase, triose. This is here is I. Add I here. Triose phosphate isomerase, glycerol 3-phosphate dehydrogenase, phosphoglycerate kinase, phosphoglycerate mutase, enolase, and pyruvate kinase. These are the 10 enzymes in the 10 process of glycolysis. We will see in the next few minutes what are the molecules come in and what are the molecules come out from the process. In the first step, ATP come in, ADP come out. In the third step, ATP come in again and ADP come out. In the sixth step, NAD oxidized form. NAD means nicotinamide adenine dinucleotide. This plus indicates it is the oxidized form of the NAD molecule, plus the inorganic phosphate. I represents inorganic and P represents phosphate. So inorganic phosphate, it yields NADH and hydrogen ion. In the seventh step, ADP will be converted into ATP. In the ninth step, there is no coming in molecule. Water molecule will leave the pathway. And in the 10th step, ADP will come in to make ATP. These are the coming in and the coming out or leaving molecules. What is the pathway looks like generally? The glycolytic pathway, considering the all metabolites, all enzymes, and coming in molecules and the leaving molecules, leaving the pathway. The first step is converting glucose, which is 6-carbon compound, into glucose 6-phosphate. This 6-phosphate comes from this ATP molecule. The enzyme involved in the process is hexokinase or glucokinase, the first enzyme. It is a kinase enzyme. If there is involvement of ATP molecule in the process, it could be coming in or making of ATP or using of ATP. There is a name kinase in the enzyme. Remember that kinase enzyme. In the second step, glucose 6-phosphate converts into fructose 6-phosphate. This is just isomerization. Isomerization means rearranging the molecule. Okay, rearranging the molecule. Because glucose 6-phosphate is 6-carbon compound, here is phosphate also. Fructose 6-phosphate is 6-carbon compound. So just the components are the same, the elements are the same. The difference is rearranging the components. So isomerization, and the enzyme is isomerase, which works on the compound. So phosphoglucose isomerase or phosphohexose isomerase, because these molecules are 6-carbon molecules or hexoses. In the third step, fructose 6-phosphate, which is 6-carbon compound, converted into fructose 1,6-bisphosphate, which is also 6-carbon compound. The enzyme is phosphofructokinase, and the process is irreversible, only to the forward direction. Here is also the kinase. The enzyme is kinase because there is involvement of ATP. Then in the fourth step, fructose 1,6-bisphosphate will be broken down into two molecules. The two molecules are glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. This is the step which is based to name glycolysis. Lysis means breaking down. So the breaking down step is here. And in the fifth step, these molecules rearrange, or just isomerization process takes place, and these molecules are the 3-carbon molecules, because the 6-carbon compound is breaking down into the 3-carbon compounds. These molecules can be interconverted, and therefore the process is isomerization again. Triose means the sugars having 3-carbon, trimine 3, OSE indicates carbohydrate, so triose phosphate, there is also phosphate in the compound, so triose phosphate isomerase. This dihydroxyacetone phosphate will not directly enter into the next process. It should be converted into glyceraldehyde 3-phosphate. Then in the sixth step, glyceraldehyde 3-phosphate will be converted into 1,3-bisphosphoglycerate. The enzyme is glyceraldehyde 3-phosphate dehydrogenase. Here it is a redox reaction. Here is adding of hydrogen in the process. This is oxidized form, this is a reduced form. Therefore, there is what? Redox reaction. If there is redox reaction, just there will be dehydrogenase enzyme. Okay, consider that. So the molecule is glyceraldehyde 3-phosphate, and there is the process of redox reaction. So glyceraldehyde 3-phosphate dehydrogenase. In the process, just consider this molecule, nicotine amide adenine dinucleotide. The oxidized form is converting into nicotine amide adenine dinucleotide, the reduced state, in the sixth step. In the next step, seventh step, 1,3-bisphosphoglycerate. Here is adding of inorganic phosphate. So here is only one phosphate at the third carbon of the glyceraldehyde molecule. There is adding one more phosphate here. You can see phosphate is coming into the process. Therefore, here you will get two phosphate molecules, 1, 3, at the first carbon and at the third carbon of the 3-carbon compound. So bis means 2. So 1,3-bisphosphoglycerate. Then 1,3-bisphosphoglycerate will be converted into 3-phosphoglycerate. The enzyme is phosphoglycerate kinase. Again, you can see kinase. It is involvement of ATP. So kinase enzyme, phosphoglycerate. The compound is phosphoglycerate, and there is involvement of ATP and the name phosphoglycerate kinase. In the next step, 3-phosphoglycerate will be converted into 2-phosphoglycerate. This is just rearrangement or isomerization. So the enzyme is mutase. Mutase is a kind of isomerase enzyme, and phosphoglycerate, the compound is phosphoglycerate here, phosphoglycerate here. And the process is isomerization, so phosphoglycerate mutase. In the ninth step, 2-phosphoglycerate, this compound will be converted into phosphoenol pyruvate. Here is a making of enol compound or enol molecule. So the enzyme is named as enolase. Again, the process is dehydration process. Dehydration means removal of water. So in this step, there is removal of water as the ninth step. Phosphoenol pyruvate will be converted into pyruvate in the last step. This is the final step of glycolysis. So the enzyme is pyruvate kinase. Here is pyruvate formation, and here is the involvement of ATP in the process that is making ATP. So kinase, pyruvate kinase. These are the 10 steps. What are the things you have to consider in the process are the 3 steps, step 1, step 3, and the last step. These are irreversible. Okay, irreversible. The others are reversible. Okay, reversible. So irreversible means just to one direction. This is we call irreversible. 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 To the both direction we call reversible. 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 The majority of the processes are reversible in the glycolysis. The other thing you have to consider are just multiply every step after this step, after the 5th step, multiply everything by 2. Okay, this one, multiply this molecule by 2, multiply this by 2, okay, this by 2, this indicates multiplication. So multiply this compound by 2, this by 2, this by 2, except enzymes, just multiply everything by 2. Then finally, you will get from one glucose molecule, 2 molecules of pyruvate having 3 carbon. So 6 molecules of glucose is converted into 3 carbon molecule, which is pyruvate. And what is overall reaction of glycolysis? Glucose, which is 6 carbon compound, plus 2 NAD oxidized form, plus 2 ADP, plus 2 inorganic phosphates will give us 2 pyruvate, 3 carbon compound, 2 molecule of 3 carbon will give us 6 carbon. So the balanced chemical equation. Plus 2 NADH plus 2 hydrogen ion plus 2 ATP, which is a net ATP because it says net. Because there are 4 ATP gross. Okay, there are 4 ATPs, 4 ATPs, gross ATPs, 4 ATPs, which is gross. Okay, gross means total. Okay, total 4 ATPs made, and 2 ATPs utilized in the first processes. In the step 1 and the step 3, 2 ATPs utilized. So when you subtract that 2 ATP, then you will get 2 net ATP. 2 net ATPs. This is just in the aerobic condition, that is in the presence of oxygen. There is oxygen here, okay, in the presence of oxygen molecule. If there is no oxygen, the process will be glucose plus 2 ADP plus 2 inorganic phosphate. There is no oxidation reduction process if there is no oxygen in the anaerobic process. Therefore, you will not see NADH molecule involvement in the process. And 2 lactate. The molecule is not pyruvate. Here, lactate molecule. And 2 net ATP plus 2 water molecule. These are the things. What are the things you have to consider in the glycolysis as a takeaway? There are 10 steps. And there are 11 metabolites, that is from glucose to pyruvate. There are 11 metabolites in the 10 steps. There are 10 enzymes in 10 steps. Each step need enzyme. 3 steps are irreversible. Step 1, step 3, and step 10. The other steps are reversible. 2 ATPs made, 2 NADH made from 1 glucose molecule. Multiply every metabolites and coming into or leaving molecules by 2 after step 5. Look, in this process, because the 6 carbon compound glucose is broken down into 2 molecules of 3 carbon compound. Therefore, 3 carbon, all are 3 carbon compounds, 3 carbon, 3 carbon, 3 carbon, 3 carbon, 3 carbon. Therefore, you will multiply by 2 every compound and every metabolite except enzymes. No need to multiply enzymes. And the other takeaway is it takes place in cytosol or cytoplasm. It is both aerobic and anaerobic, and other monosaccharides such as fructose and galactose also can enter in glycolysis. Not only glucose take the pathway, but the major is glucose. That is why we look here in the pathway. The first molecule is glucose. Even though it is a glucose, which is a major molecule in the glycolysis, there are also entering of fructose or galactose, the monosaccharides, in the glycolysis. These are the things I want to discuss in the glycolysis. Thank you so much. If you have any question, please leave in the comment and I will respond. Please subscribe to my channel. Thank you so much. Bye bye.